It would be safe to say that no new library technology since the barcode has revolutionized library circulation as much as the radio frequency identification chip, or RFID chip. Radio frequency ID chips offer many advantages over traditional barcodes. For one, you needn't touch the chip or even be able to see it in order to extract the information. As the target, as it's called, passes near the detection equipment, a radio signal is transmitted from the computer system to the chip. When the radio frequency energy strikes the antenna, enough energy is transferred to the chip to wake it up from slumber. The chip then sends a signal back to the system, identifying not just a number as in the case of a barcode, but potentially the entire bibliographic record, or the entire borrower record. This raises some privacy concerns, since patron information could presumably be detected by other radio frequency ID equipment, not simply that in the library. If there's an RFID chip on your library card, or for that matter, in the collar of the shirt you just bought, malicious, identity thieves, and legitimate government agencies could extract that information as you pass by their detection equipment. However, RFID chips offer endless possibilities for enhanced services. For one thing, taking inventory in the stacks would simply be a matter of walking up and down the aisles with a portable antenna. Even if the books had fallen down behind the shelves, the antenna would still detect them. Furthermore, the RFID system eliminates the need for magnetic theft detection strips. When a target passes through the sensors, full information about the book, including whether or not it's been charged out, is transmitted back to the system. If someone forgets to charge out a book, staff can now inform them not simply that they have some book or some video, but the exact name of the item which they failed to check out. Powerful magnets are necessary to activate and deactivate magnetic theft detection strips. This makes magnetic theft detection unsuitable for use with videotapes or other magnetic media such as computer disks. Not so with RFID tags. Another advantage of RFID chips is the ease with which they can interact with automated sorting equipment, such as robots which reshelve books or retrieve them from the stacks on demand. These are two types of RFID labels. This is the antenna, and there's the actual chip. This round tag is useful for identifying disks. Conveyor belts for retrieving books from the stacks or returning them there have been in use at least since the 1970s. However, new technologies offer the possibility of harnessing robotics for sorting and distributing library materials. The process is simplified if those materials are identified with RFID tags. It's no longer necessary for someone to open the book to the barcode and scan it. The system detects anything that comes within proximity of its sensors, regardless of the item's orientation. Since full information about the book, including its call number, can be stored in the RFID tag, the robot should have no trouble locating the proper shelf. The equipment you're looking at is designed to pre-sort materials which have been returned to the library. However, by extension, we could have a robot roaming the stacks, performing inventory functions, detecting items that were out of place, and either creating a printout for human intervention or actually retrieving those items and putting them in the right places. Systems like these are already in wide use among courier companies such as UPS and Federal Express. The systems are intelligent enough to detect items which should not be returned to a library, such as a pair of pliers or a snowball. This facility is useful if you wish to have patrons returning their books in a shopping mall, for example, or at an outdoor book depository slot. Finally, just like an automatic teller machine, the system creates a receipt, thus reassuring the patron that all transactions have been completed successfully.